So in this video, we're going to take a look at ionic bonds and Coulomb's law, and we're going to take a look at sodium chloride, common salt, or otherwise known as the mineral halite, as an example. So in our prior videos, we've talked a little bit about the notation of electrons. Electrons will fill in shells at going from low energy to high energy, and if you take a look at your periodic chart, and you look at sodium, you'll see something listed like this, where it'll say 1s2, 2s2, 2p6, and then 3s1. And the 1s2 just means that we're filling in the K shell. The K shell can only hold 2 electrons. The K shell only has an s orbital and nothing else. The 2 here means that we're filling in the L shell. The L shell can contain both s and p orbitals. The s orbital can only hold 2 electrons, while the p can hold 6, and then it's full once it has 8 electrons. And then to bring in that final electron, the sodium atom starts filling in the 3rd shell, and that would be the M shell, and it brings in 1 electron. If you take a look at this notation over here, though, you'll notice when you look back at the periodic chart that that is the same elemental structure for neon. So we can rewrite sodium, its electronic structure, as simply neon with some square brackets, and let's get rid of that, a 3s1, just ignore this stuff here. All right. Now, let's take a look at its potential companion, chlorine. So chlorine, its full electronic structure would be something like this: 1s2, 2s2, 2p6, 3s2, 3p5. So we have the first shell, the K shell, completely filled. The L shell here is also filled. Here we're starting to fill the M shell, or at least the S and P orbitals. There is also a D orbital, but as we talked about in an earlier video, those D orbitals are just kind of a special case. So we're coming close to at least filling the P orbitals in the M shell, except we're just 1 electron short. If chlorine can find a way to get rid, or excuse me, to add 1 more electron and turn that 3p5 into a 3p6, it would have a filled orbital. And so for chlorine, what it would like to do is bring in another electron. That would mean that it would go from being neutral to having a minus charge. And sodium, take a look at sodium here. It's got a single electron in its outermost 3rd orbital, or 3rd shell. If it could simply get rid of that fellow, then it would be left with a noble gas state. If we have 3p6, by the way, the noble gas that chlorine would be approximating would be argon. And so it's a simple matter for them to trade. If chlorine can grab onto the electron that sodium doesn't want, then chlorine would have a filled 3p orbital, giving it an argon-like structure, and sodium, getting rid of that 3s1, would have a neon-like structure. So in the the formula, sodium chloride, we have sodium approximating a neon-like structure and chlorine approximating an argon-like electronic structure, where sodium simply allows that electron to be given away. It just gives it away to chlorine, and that is the fundamental aspect of an ionic bond. An ionic bond is one where atoms trade electrons, where there is a transfer. That's probably a better way of describing it, a transfer of electrons from one element to another.